Dear students, welcome to all. Today we are going to study how amplifiers are classified. So before learning individual amplifier circuits, it is important to understand why different amplifiers are required for different applications. First we see the what is the amplifier. All of you know about the definition of amplifier. An amplifier is an electronic circuit that increases the strength of a weak signal without changing its original shape or information. The signal may be voltage, current, or power. So now most of the engineers classify amplifiers in different ways based on their application. Let us discuss each classification one by one. Okay. There are three important types. First one is voltage amplifier. Suppose a microphone produces only 10 millivolt of voltage. So this voltage is too small to drive the next stage. A voltage amplifier increases only the voltage level while drawing very little current from the source. So input voltage is low voltage, output voltage is high voltage. So it has high input impedance, moderate output impedance. The applications of voltage amplifiers are, it is used as an audio preamplifier, sensors, instrumentation. Example, if the input voltage is 20 volt, 20 millivolt, output is 2 volt. So therefore the voltage gain is equal to output voltage divided by input voltage, which is equal to 100. So the amplifier increased only the voltage. So this type of voltage is called voltage amplifier. So next, current amplifier. So this all are based on the nature of signal. Next, current amplifier. Sometimes voltage is already sufficient, but the available current is very small. In such case, we use a current amplifier. So its main work is to increase the current. So it generally has low input impedance and high output current capability. It is used in current sensors, motor driving circuits, and current controlled devices. So another one type of amplifier is called power amplifier. So now imagine you want to drive a loudspeaker. A loudspeaker needs both sufficient voltage and sufficient current. Since we know that power is equal to voltage into current. So a power amplifier increases both so that high power is delivered to the load. So this is usually the last stage of an amplifier system. So it is used in audio systems, public address system, radio transmitter. Okay, so these are the main categories of amplifiers. So next, based on the frequency range, signals have different frequencies. Not every amplifier works efficiently at every frequency. So first one is audio frequency amplifier, that is AF amplifier. So humans can hear frequencies approximately from 20 Hz to 20 kilohertz. Okay, so it is used in television, mobile speaker, home theater, public address system. So next is RF amplifier. It is called radio frequency. So these amplifiers work at very high frequencies. They amplify radio signals before transmission or after reception. So it is used in mobile communication, satellite communication, radar, and television transmitters. So next one is IF, intermediate frequency. So in radio receivers, directly amplifying RF signals is difficult. So first the RF signal is converted into a fixed frequency called the intermediate frequency IF. So then an IF amplifier amplifies this signal because the frequency is fixed. It is better gain, better selectivity and lower noise. It is used in AM receivers, FM receivers and television receivers. So next, based on the transistor configuration, there are three terminals. We know that emitter, base, collector. Depending on which terminal is common, we obtain three configuration. First one is common emitter configuration. Okay, because it provides high voltage gain, high current gain, high power gain. So this is the most widely used amplifier configuration. So one important point is to remember is output is 180 degree out of phase with the input. So that means when input goes positive, output goes negative. So this phase reversal is an important examination point. So it is used in general purpose amplification and audio amplifiers. So next, common base amplifier. The base is common. So it has high voltage gain, very low input impedance, excellent high frequency response because of its good high frequency performance. It is used in RF circuits. So next, common collector configuration, that is called common collector amplifier. It is also known as emitter follower. If the voltage gain is nearly 1, why do we use it? The answer is because it provides very high input impedance and very low output impedance. It acts as a buffer stage. It prevents loading between two circuits. Application includes impedance matching. Okay, next, coupling method. So based on the coupling method, we can classify the amplifier RC coupled amplifier, transistor coupled and direct coupled. When multiple amplifier stages are connected together, the method used to connect them is called coupling. RC coupling amplifier. RC stands for resistor capacitor coupling. Here a capacitor connects two amplifier stages. The capacitor blocks DC but allows AC signal. So the advantages of this RC coupled is simple, low cost, good frequency response, most popular in audio amplifier. So it is used in audio amplifier, television, public address system. So next one is transformer coupled amplifier. Instead of capacitor, a transformer connects with stages. So it has a better impedance matching, higher power transfer and suitable for power amplifier. So it is used in audio output stage and power amplification. So next one is direct coupled amplifier. Here no capacitor and no transformer are used. The stages are connected directly since DC is also amplified. These amplifiers are useful for DC signals, very low frequency signals. And it is used in operational amplifier, instrumentation amplifier and medical equipment. Okay. So next, based on the continuous, that is power amplifier. Mode of operation. So we discussed amplifier classification based on the nature, frequency, transistor and coupling method. Continuing with the three remaining classification, mode of operation, number of stages and applications. So these classifications are very important because they all tell us how an amplifier behaves, how much power it consumes and where it is used. So based on the mode of operation, class A, that is Before studying each class, let us understand one important term. What is conduction angle? The conduction angle is the portion of the input signal during which the transistor remains on. So one complete AC cycle equals 360 degree. Depending on how much the transistor conducts, amplifiers are classified into different classes. So first one is class A. The transistor conducts for the entire 360 degree of the input signal. So that means even when there is no signal, the transistor is already conducting. So it has very high linearity, low distortion, and excellent signal quality. So this disadvantages of this amplifier is low frequency, low efficiency, produces more heat, and higher power consumption. So its efficiency is around nearly 25% to 30% approximately. The easy example for this is think of a classroom fan. Even if nobody it is in the room, the fan keeps rotating continuously. Similarly, the transistor never turns off. Class B amplifier. The transistor conducts for only 180 degree, which means one half of the input waveform. Since one transistor amplifies only one half, two transistors are normally used in push-pull configuration. So it has much higher efficiency, less heat generation. The disadvantage is there is a small dead zone near zero crossing. This produces crossover distortion. Class AB. Can we combine the advantage of class A and class B? Yes, that is called class AB. Here, the transistor conducts for more than 180 degree but less than 360 degree, typically around 200 to 300 degree. So it has a higher efficiency and lower distortion, most commonly used practical amplifier. So applications are home theater, car audio, professional audio amplifiers. Next, class C. So less than 180 degree. This means the output waveform is highly distorted. So naturally students ask, if it is distorted, why do we use it? Good question. It is used only in tuned circuits. A resonant LC circuit reconstruct the signal. It has a very high efficiency. Then it is used in RF transistors, radio communications, oscillator circuits. So next, class D. So it is a switching amplifier. Here the transistor is not operated in the active region. Instead, it works like a switch. Only two states, on or off usually. PMWM, that is pulse width modulation, is used here. So it has very high efficiency, very low heat generation, and small size. So efficiency is greater than 90%. So it is used in Bluetooth speakers, mobile phones, home theater, portable electronics. E and F amplifier. So there are advanced switching amplifiers. They are mainly used in RF communication, microwave transistor, high frequency wireless system. It has extremely high efficiency, suitable for high frequency application. Usually these are studied in advanced communication courses based on the number of stages. Now let us discuss another classification. Sometimes one amplifier stage is enough. Sometimes multiple stages are needed. So only one transistor is used for single stage amplifier. So it is a simple design, low cost and moderate gain. It is used in smaller electronic circuits, laboratory experiments. So multi-stage amplifier. Here two or more amplifier stages are connected together. Each stage increases the signal further. Overall gain becomes gain is equal to gain 1 into gain 2 into gain 3, etc. So the advantages of a multi-stage amplifier is very high amplification, better performance. So it is used in television, radio receivers, instrumentation and communication system. For example, suppose stage 1 gain is equal to 20, stage 2 gain is equal to 30. So therefore overall gain is equal to 20 into 30, which is equal to 600. So that is why multi-stage amplifiers are preferred whenever large amplification is required. So next, classification based on application. The last one, small signal amplifier. This amplifier handles very weak input signals. It may be only a few millivolts. The objective is accurate amplification, not high power. So it is used in sensors, medical instrumentation, audio amplifiers. Then large signal amplifier, that is power amplifier. The amplifier drives heavy loads. Example, loudspeaker, motor, relay. The objective is maximum power delivery. So it is used in audio output stage, public address system, power electronics. The next one is operation amplifier. We can say it is an op-amp, commonly used amplifier. It is a high gain amplifier. It has very high input impedance, very low output impedance, extremely high gain, using external resistors. It can perform amplification, addition, subtraction, integration, differentiator, filtering and comparison. So it is used in signal conditioning, analog computers, control system, medical electronics and instrumentation. One of the most famous ICs is IC741 amplifier, operation amplifier. Okay, this completes the classification of amplifiers. So understanding this classification will help you choose the appropriate amplifier for different electronic and communication system applications. Thank you.